Right, so the first thing we needed to do, and this is the first part of our method, is it's a fairly straightforward one. It's finding the density of a regular shaped object. So all we need to do first of all is we need to use this equation, density equals mass divided by volume. So the first thing we need to do is work out the volume. So a regular shaped object is anything like a cube like this. Now the easiest way to remember how to work out the volume is we normally say things like we are going to times, so volume would be, and it would be length times width times depth. But the easiest way I find to remember is to actually take a corner of our block, okay, and it doesn't matter what we call each of these sides, but we are talking about the 3 sides that go away from the corner. Then we know we've got the correct 3 sides. So that's what we're going to do now. So the first one I'm going to do is, it says in ours, it says height. So if it was stood that way, then that would be the height. But I'm just going to take this corner and I'm going to measure all 3 from this corner. So the first one we've got is 4.5. So that's the first one, that's our first measurement, and that's going to go in on the height as 4.5, and we're using a wooden block. So then we've been asked for width. Now again, I've measured this one, so I'm going to make my width the long one. And if I measure that again, you can see that one is 6 centimeters. And so that goes into our width measurement. And hopefully, if you've got this open, you can write this directly into your Google Classrooms now. So you should be writing these directly in. And then we've measured this and this. So we could have worked the area out, but now we need the depth. So we're going to do the third one, which I'm going to make our calculations easy. I know it's really 3.8, but we're going to go 4. So that's 4 centimeters. And so to work out the volume, we would just times those 3 together. So that's something you need to do now yourselves. And then the next thing you're going to need is the mass. Well, that's really easy. And hopefully you can see here, I've got my mass balance. And I'm just going to place that on there. And that gives us our mass of 66.13. And so we have now just done, and this is finding out the density of a regular shaped object. So now you've got those, grab your calculators out, quickly do the calculations and put that into your Google Classroom. Hopefully what you got is you worked out 108 and 0.6. Now remember the unit here is grams per centimeters cubed. Okay, because we're using grams and centimeters. If we'd used kilograms and meters, it would have been kilogram per meter cubed. So the next one is to work out the density of a liquid. So to work out the density of a liquid, again, we need exactly the same thing. We need to find out the volume. We also need to find out the mass. So it's easy to find the volume of a liquid. We can just use a measuring cylinder. Okay, so there's my measuring cylinder. I'm just going to use a measuring cylinder. Now the one for this one is to find out the mass. So what we're going to do to find the mass out, the first thing we need to do is know the mass of the measuring cylinder. So I'm just going to place my measuring cylinder without anything in it onto the balance scales. So we're going to do water first. So without anything in it, it's 74.84. 0.4. And again, that goes straight into your Google Classrooms. We're then going to add a volume of water. Okay, so I'm just going to do that off screen, and I'm going to add, hopefully, 20 millilitres. Now the beauty with water is that 20 millilitres happens to be 20 centimetres cubed. So every milliliter is a centimetre cubed in volume. Now I'm going to be as accurate as I can. Okay, so we now have a volume of 20. So we can put that in straight away. So we know our volume is 20 centimetres cubed because it's 20 millilitres. Now what we're going to do is we're going to measure the mass of the measuring cylinder with the water in it. And that comes to 94.48. And so all we need to do now is take the mass with the water away from the mass of the cylinder without the water, and that will give us the mass of the liquid that we've got. So I'll let you do that. We then have mass and volume. We can divide the two and we can put the density in there. So we're going to do the next one. We're going to do oil now. Now the one thing to do straight away is to actually, I'm going to remeasure just to make sure, because I've been messing with it. I've got some of the water still in there, or I've got a little bit more water out than I did. So I still need to know what it is at the start. And you can see there, it's just slightly different. So this is our start for oil, is 74.56. Okay. I must have had a little bit of liquid already in there. And I'm going to use vegetable oil. Okay, so some sunflower oil straight from my kitchen. And whilst you're doing those other calculations, I'm going to very quickly put, and again, I'm going to use 20. So my volume again is 20. I'm going to put that on the balance scale. And this time I have 91.84. So again, I'm going to pause there so that you can work out the mass by taking this weight away from the weight of the cylinder, which will give you the mass of the liquid, and then very simply it's the mass divided by the volume of 20. So hopefully everyone's got that, and what you should have found is that the density of the water is around about 1, because actually if that was completely accurate, the density of water is actually 1. So and the density of oil you should have found is less than the density of water. And of course this is why oil floats on water. So if it's less dense, two materials are less dense, so the oil is less dense than the water, it means it will float. Anything that's more dense than water will sink. So we're going to move on now to the next one, which is an irregular shaped object, and this is the one that always trips people up. So an irregular shaped object is something, the difficulty we have with this is trying to find its volume. So a regular shaped object is easy, we can just measure it to work out its volume. Liquid is easy to work out the volume, we just put it into a measuring cylinder. But if I have an unusual shape like this, then I need to be able to find the volume. So what I'm going to do is I'm going to use the measuring cylinder again, and again I'm going to use a start volume of 20 centimetres cubed. It doesn't matter what volume you use, as long as it's enough for the object to sink. Okay, so that we now have, it's very hard for you to see there, but we have a start volume of 20. So the first thing we need to do is we need our initial volume of water as 20. Now what I'm going to do is I'm going to take, this is my object, so I'm just going to use just a piece of plasticine, and I'm going to work, the mass is easy, so I'm just going to place that on the balance scale, and that gives me a mass of 7.16, so that goes in here. And now all I'm going to do is literally just place that inside my measuring cylinder. And what you should see is that the volume has gone from 20, it's gone up. Now that the amount that it raises, the amount that the volume has gone up by, is the volume of the plasticine block. So I'm just going to take that up so I can read it at eye level. And that comes to 25 centimeters cubed. So our end volume is 25. And again, the rest of this is straightforward. You need to now take the final volume away from the initial volume, which will give you the volume of the plasticine. We've got the mass, so you can just, in here, calculate the density. Do that now straight into your Google Classroom. So what you should have found there is you should have found that the plasticine has got a higher density than water, and of course we know that because the plasticine has sunk in the water. Okay, so the plasticine has sunk. If I put it into a very viscous liquid, so let's say I managed to find a liquid that was above the density of the plasticine, then it would float. So if we look at the density of our wood, we can see that the density of the wood is actually less than the density of the water, which is why wood floats on water. What we've just done, and this will mean that you'll be able to go away now and do the practical quiz that goes along with this, so the PAG quiz, which is the exam style questions. So as soon as you've done the calculations for that other one, you should be able to hand that in straight away to me now. You just hit, once you've done calculations, hit the hand in button, and then go straight to assignment 4B. And assignment 4B is basically questions on the method that I've just shown you. So a quick run through: to find out the density of a regular shaped object, you work out the volume of a block by timesing the height by the width by the length, or as I've just said, those three sides off the corner. Using a balanced scale to find the mass, and then you do mass divided by volume in order to find the density. Now, when you're answering exam style questions, if it's a 3-mark question, you really do need to put it into those 3 bullet points. The next one we looked at was volume of irregular shaped objects. So again, you need to be saying you find the initial volume of the water, place the object in the water, find the final volume of the water, and that the amount in which the water is being displaced is the volume of the block. But if it's asking you then how you find density, remember to go on and say that you need to weigh the irregular shaped object to find the mass, and also then how you calculate density using the mass divided by volume.